Howdy, friends. How's it going? Rosendo from MLH here. We're just going to wait for folks to get through the ads really quickly, maybe a couple of seconds. In the meanwhile, let me know where you're joining us from, any part of the world. Yeah, like I said, this is Global Hack Week, Rosendo from MLH. So we do expect a global crowd. I really do hope that y'all are excited for today's workshop. We've got someone from Egypt. That is awesome. Love it. We've got some folks from Mexico, Bangladesh, Italy. The chat is flooded right now. We've got Michigan in the house and Malaysia. That is such a great assortment of places. You have no idea how happy that makes me feel. Like I said, we have a great workshop in store for y'all today. If you've never heard of green software before, you are about to be introduced to one of the foremost experts on the topic of that like segment of software development. So yeah, get your thinking caps on, come up with some awesome questions, and get ready to learn something new. Without any further ado, let's bring up Paul Young from GitHub Sustainability, and please give him a warm welcome, y'all. How's it going, Paul?
Hi. Hello, everybody. And I love hearing that we've got an international contingent. I'm based in Los Angeles, but you can hear by my accent if you're familiar with Australian accents. I'm an Aussie originally, but now American. So yeah, I heard Egypt, Malaysia, Italy, Mexico. I'm sure there's more. Thank you so much. I'm going to run through a bit of content. I do speak fast with my thick accent, so if you want me to repeat something, just post a comment. Rosenda is going to share comments and links and things as we go. I'll be keeping an eye on those, so I'm very happy to take questions throughout. And we're going to have plenty of time for questions at the end, and we can talk about the topics we cover in this. We can also talk broadly about climate change and sustainability. I'm here for you for the next hour as we go through this content. Great, but we're going to talk about the green side of software, and I'm going to talk about how doing good for the planet and helping to tackle the climate crisis can be really good for your career. But first, let me ground this problem in the science. And what do we mean when we're talking about climate change? So the graph that I've got up on the screen now is actually from an open source repo on GitHub. And you can see the link on the screen. It's from Ed Hawkins, who's a UK-based climate scientist. And he has these awesome climate visuals that he's shared open source on GitHub so that anyone can use them that kind of visualize the science behind climate change. And this graph, to me, really explains the issue that every single one of us, wherever we are in the world, is dealing with. So the x-axis on the graph shows recorded human history, so year 1 to 2023. The blue on the bottom of the graph is the global temperature change. So that's the range in which temperatures in the world have changed since over the last 2023 years. And the red graph above it, laid on top of the temperature change, is carbon dioxide levels at the same time, which is measured through the atmospheric concentration, ppm, parts per million of carbon dioxide in the atmosphere. And you'll see right up to that dotted line that comes down the y-axis with the invention of the steam engine and the start of the Industrial Revolution, you'll see that carbon dioxide levels were really static in our atmosphere. We weren't burning a lot of fossil fuels. We weren't digging up coal, oil, drilling for oil, drilling for natural gas at scale, and burning it to power machines. We had campfires and small bits of industry. We had a small amount of livestock out there. And so the carbon dioxide levels did not change for much of the time that humans have been around that we can measure. And similarly, global temperature change stays very static with carbon dioxide. A lot of engineers, I'm sure, on the call, like this is science. It's a straightforward scientific reaction. What happens is that more carbon dioxide in the atmosphere, once a fossil fuel is burned, CO2 is one of the gases, one of the greenhouse gases that it releases. It's the one we're kind of most concerned about and track the most carefully. But there are other gases like methane and others that also create global warming. But when these gases enter the atmosphere, they sit in the Earth's atmosphere for something like 100 plus years. And it's almost the way I explain it to my 4-year-old daughter is it's like the Earth's wearing like a warm blanket because the sunlight can't reflect as much. And so we hold more heat. And so what happened with the invention of the steam machine is that humans started through the Industrial Revolution digging up and burning fossil fuels for energy, which is a good thing. We need energy, but we didn't quite realize the outputs. And what that meant was more and more carbon dioxide in the atmosphere. And you'll see this graph ends at 421 ppm. There's actually more ppm than that in the atmosphere now. We're setting new records for carbon dioxide levels every day, basically. And as that has shot up, as humanity has burned more fossil fuels, you can see the temperature has started to rise because of those gases being in the atmosphere. We're actually tracking, so that's 1.2 degrees Celsius of temperature change by 2023. I just read yesterday that we're tracking for this year to be above 1.5 degrees Celsius across this year. And that's a really concerning level for climate scientists, because 1.5 degrees is sort of the line that we've set for global agreements. You might have heard of the Paris Agreement. That's the line that all the nations of the world agreed to, that we need to try to make changes to keep the temperature change below 1.5 degrees Celsius, because above 1.5 degrees Celsius, we start seeing really bad changes for ecosystems, and it will damage human life. So that's kind of grounding in the science. And then what does this mean? So how to think about this. So here's another graph. This is from July 22, 2024, was Earth's hottest day that we've ever recorded. And in this graph, you can see global temperature from 1980 to 2024. I was born in 1983. I might be one of the oldest people on the call, but this was my entire lifetime, basically, is on this chart of global daily temperature. And you can see the red line into the purple line is this year. And the hottest year that we're seeing, we may well be this year. We're not sure until we get to the end of the year if we will be or not, but we're warm. And the hottest single day ever recorded in human history was July 22, 2024. And then we also see effects like this. So you'll see this chart looks very, very similar. This chart was the ocean heat content in the Gulf of Mexico. So as the world was so hot, that warms up the oceans. The oceans also actually suck in a lot of the carbon dioxide we release. The main way that we suck in carbon dioxide is actually more into the ocean than trees. But this shows the ocean heat content. And on October 7, 2024, so you can see this year how hot it's been getting. We have this really hot Gulf of Mexico, and then that led to two extremely strong hurricanes hitting America, wiping out towns in North Carolina, Hurricane Milton, and then Hurricane, I think it was Helen or Helene. The reason these hurricanes get bigger is because, again, it's a scientific reaction. More heat means more energy in those clouds, means bigger storms. They also hold more water, and they have much more disastrous effects. This is the type of climate disaster we're seeing directly linked to weather, directly linked to heat, and the heat is directly linked to us burning fossil fuels. So that's the science of the problem. And we're going to talk a little bit about the solution. And the solutions, honestly, are really humanity needs to stop burning fossil fuels as quickly as we possibly can. We need to replace fossil fuels with renewable energy, with solar, with wind, with nuclear, with other sources that do not produce fossil fuels. So we can keep growing our economy, so we can keep building things, so that we can keep, growing as humans. But we just need to replace fossil fuels with renewables. That's going to get the problem at least slowing. And then we'll work out carbon removal at the same time, is the other thing that humanity needs to do to get back to levels of temperature that will allow us to not see these types of disasters and not damage ecosystems and see ecosystems go extinct. So that's the framing. And what I'm going to talk about is what we can do as developers and as technologists, because we have a huge opportunity. We have an opportunity to make changes in our individual life, and we can talk a little bit about that in questions if you're interested. But for me, at least, the way I frame it is the impact I can have on this problem through my career. And I believe this is the most important problem that's going to impact the rest of humanity, both now, we're already seeing these effects, but particularly for the lifetime of my children. The younger you are and the more years you're going to be living on the planet, the worse this is going to get if we don't take action. And as you're going to see in this talk, when we build technology, that does produce and that does require energy, and that does produce fossil fuels being burned. And so what can we do to minimize the footprint of our technology? And what can we do with technology to accelerate climate solutions? That's where it gets really exciting. And the other exciting bit for framing is working on climate action and sustainability can really help grow your career. Like, this is going to be the great challenge for humanity for the next decades. And so learning about this and finding ways to apply it within your work, I think is going to be really valuable for your skill set. So bring it back to Career Week while we're here right now. I'll share a little data on that. This is my most word-heavy slide, I promise, in the whole presentation. But I had to share it because just yesterday, LinkedIn released their Global Green Skills Report 2024. And they do this huge report every year to analyze globally how are green skills wanted by employers, where are they growing, how are they changing, like what are they seeing on LinkedIn, which is probably the best place on earth to see how jobs are changing. And I'll call out a few of the stats on the side, but first I'll draw your attention to the graph. This is by 2050, so you'll see each year from now up to 2050 on the x-axis, is the light green higher level in the graph is the demand, is the amount of jobs that they're going to require what they call green talent and sustainability skills. And the dark green, the lower level that's starting, they both start, at about 1 now, but that only gets to 2.5 and the other goes up to 5. There's going to be a big gap between people that have the skills and jobs that are available. They think the gap between talent supply and demand with green skills is going to balloon to 101.5%. So we need to double the size of the green talent pool by 2050 to achieve the sustainability goals. So that's great, because taking on skills like we're about to go through in this course, as you think about your career, you're probably maybe going to be working all the way to 2050. I assume you probably will be at the stage of your career you're in. There's going to be more and more opportunity available for those with green skills. So there's a couple of things. I put them in bold, but they probably don't jump out that much. But already the hiring rate for job seekers with green skills is 54.6% higher than hiring rate overall. So if you have green skills, what LinkedIn is seeing across all industries, that you're more likely to get higher. And in the US, that raises to 80.3% higher, Ireland 79.8% higher. So you have green skills, LinkedIn sees that there's more chance that you'll get hired regardless of what you work on. And then particularly for us working in technology that in this report sees the sharpest 1-year spike in green skill demand. The number of job postings in tech that require green skills soared 60% over the past year. That was more than any other industry. Green hiring rose 7.3%, but supply only rose 4.8%. So if you're a software developer that has green skills, like the skills we're going to go through in this report, in this presentation, you will, for many, many roles, be a better candidate. And then finally, the skills sustainability was among the fast growing in the tech industry across many countries, including Brazil, India, the US, and France. So you can just Google for this report, LinkedIn Global Green Skills Report. You can probably find your own country and your own information. But I thought this was I just had to copy paste some of the stats because I only read this yesterday and only just got launched. And I was like, wow, this is so applicable for what we're talking about today. And I also wanted to frame, before we get into the particular green software skills, why are these skills in demand? Why do businesses care? And what we're seeing is, coming from a corporate sustainability team, is that many, many businesses in the world feel that they have a responsibility to limit their environmental impact, to limit their carbon emissions in particular as they grow their business. And this is just a screen grab from an awesome website, speedandscale.com, that I'd really encourage you to check out. Speedandscale.com is a system of OKRs, objectives and key results. It's a way that in many tech businesses we manage our performance, and we have OKRs internally. The Speed and Scale team, they come out of Kleiner Perkins, the big VC firm. They built OKRs for the climate crisis. Like, what exactly do we measurably need to do as humanity to hit the goals that I talked about earlier to limit the damage from climate change? For businesses, they call out the most important thing that they want to see is that 100% of Fortune Global 500 companies commit to reach net zero carbon emissions by 2050. So having a net zero goal, we call it in the industry, is really important. And what a net zero goal is that you reduce the emissions of your business by doing things like replacing fossil fuels with renewable energy, by working with suppliers to make sure they adopt renewable energy. Honestly, renewable energy is the biggest piece here. But to reduce your emissions as much as possible, and then for what's remaining, you can work on carbon removals and other pieces like that. I'll talk a little bit later about how we think about this at GitHub and at Microsoft, who are our parent company. But what they're seeing is that already 2023, we saw 9.2%. So 1 in 10 of the global 500 companies had this goal. They think 100% will have it in a couple of years. Honestly, I think we'll get there, as well as regulation coming. But all the large businesses in the world in particular are likely to have these targets and are going to want to cross the business to be like, how can we reduce emissions? And that means that regardless of what kind of tech you're building, if you're selling to these businesses, if you're part of these businesses, if you're building technology that these businesses want to adopt, the businesses more and more not only want the technology to do its job and to be like secure and now they also think about like, well, what's the environmental footprint of that technology? And that's what we're going to talk about today is greening your code, green software, how you can, in your work, make yourself more employable, help the businesses, help the company that you work for get more stuff sold, which keeps the business growing because their clients and the business you work with are going to want the greener version of technology. And also, as an individual, this will allow you to have the biggest possible impact on the climate crisis. It's likely your work and the technology you build could have way more impact than any lifestyle thing that you do, whether you choose to ride a bicycle instead of a car or you choose not to eat red meat. Like, there's many individual options you can take. But your work, you might be able to have even more impact. At least for me, that's where I see the most impact in my life. And I transform my whole life to minimize my environmental footprint. So, moving on to greening our code. And again, please, if you've got a question as you go, I'll keep an eye on the screen. Rosendo will share them, and we will have a lot of question time at the end to tackle anything. This is a graph I just wanted to share to think about, like, what does it really mean? Like, how does my code have environmental impact? And this is a great image from the Green Software Foundation. I've shared on screen. They actually have a great training on green software. So if you're really interested after this talk, I'd encourage you to check out the Green Software Foundation at learn.greensoftware.foundation is their training, and you can go get a formal certificate that you could put on your resume and that you could tell employers you have to be trained as a green software developer. It's mainly text, but it's the best thing I've seen on how to get trained on this. But what this image shows is when you're writing code, when something's being shows up on your computer screen, like, right now you're all watching this streaming site. We're streaming through a couple of different services. Like I'm on StreamYard. You might be watching this on Twitch. Somewhere in the world, servers are running to get this stream out there. They're running in a data center somewhere, and that data center, the servers are pulling in electricity, and that electricity, the source of electricity could be clean or could be dirty. It could be oil. It could be coal power. That's kind of the dirtiest that's out there. It could be gas. And therefore, it could be streaming right now, could be releasing some CO2 into the atmosphere. Or it might be renewable. It might be in a data center that's powered by solar or wind or nuclear, in which case there is no CO2 from the energy from the stream going out. There is carbon dioxide across what they call embedded carbon. So the machines themselves, so the servers, the racks, the concrete and steel in the data center that the server's sitting in that's powering this streaming right now. So there is CO2 everywhere. So the more efficient this stream can be, the less carbon that would be produced. And so that's what I'm going to talk about is how do we be extremely efficient? One way to think about this, so the grid is really important. So where is the data center and what kind of electricity powers it? And I just wanted to frame this up because this is an important thing to sort of understand. One really cool activity, I'd encourage you to take a look if you're able to just go to this link, app.electricitymaps.com/map. Rosendo, you might be able to share this on screen so that people, if they want to, can click through. This is an open source project, Electricity Maps. They're one of the biggest climate positive projects on GitHub. I really love what they're doing. And what they do is that they map all of the electricity sources around the world. They don't have every market, so that they may not have yet be able to show your area. But this is what they produce with it. So if you see in this grid, thank you for sharing that, Rosendo and team. If you look at this, this is a screen grab of the electricity in the US around this time of day. And you'll see I'm in California. I'm in Los Angeles, California. We, at this time of day, have a huge amount of solar on our grid. Some nuclear, but we're quite, like being a light yellow, we're quite a green grid. But you also notice, if you look up in the top left at Washington, that's where Seattle is, so green. Like there's nearly no CO2 coming from Seattle. That's because there's a lot of hydropower up there. They have a really renewable heavy grid. But then you also, if you look in the middle of the map, you'll see that dark brown, like that is a dirtier grid. in Wyoming, Nebraska, Colorado, that probably means that grid's probably got a lot of coal on it. Now, if we go back to the data centers, imagine there was 3 different data centers that could be having this stream come from them. And if that data center was up there in the top left in Washington, it would be producing, at least the energy that was powering it for this stream would have no CO2. In California, it would have very little CO2 coming from the grid because there's so much solar that it would be using solar energy right now. If this was at nighttime, it would be a different story. But for right now, the sun would be powering the energy for the stream. But if the same stream was happening from a data center sitting there in Colorado or Nebraska, it might be running from a coal plant, and a huge amount of CO2 could be coming from the same job, the same stream. So understanding the grid and how we hook in is really important, and this kind of knowledge underpins a lot of the tools I'm going to show you. But being grid aware and the idea of carbon aware computing is one of the most important principles of green software. So with that idea presented, this is another great image from the Green Software Foundation. We're going to share one of their tools later. They're a great group. GitHub and Microsoft are both financial supporters and been involved for a long time and continue to be, because they're just an awesome group that's working on this topic. So what makes software green? The most important thing to think about is carbon efficiency. How do we, when we have software that we've built, when we're building technology, how do we emit the least amount of carbon possible? And there's 3 big ways to do that. One is energy efficiency. So how can we write things that consume the least amount of electricity possible? At GitHub, we call this performance engineering internally, and we have all sorts of teams that are doing jobs to make sure that the tech we build runs as efficiently as possible. So if you're using GitHub Actions or code spaces or something, we have teams that are trying to work on that code to make sure that in the most efficient way, we have the least amount of CPUs running to do the best job, because the less CPUs that run, the more efficient it is, the less energy we need and the less data centers we need to build. And so as we grow our business, internally, we're thinking about this idea, this principle of 10xing our impact. Like, could we have 10x the users, 10x the services, but on the same data center footprint? And from a sustainability lens, that would mean not only less energy going into data centers, that would also mean less data centers that need to be built, less carbon, or less steel and cement that needs to be built, and those require a huge amount of carbon. So energy efficiency is one really big piece. Like, can you really think about the most efficient way to build software and to run a job? The next piece is hardware efficiency. This is all about the actual machine. So the machines have carbon in it. Like if you look at your computer or your phone that you're watching this on, there's precious metals inside that had to be mined and pulled out of the earth. The data center that's running this has steel and concrete walls. It has racks and chips, and those all have metals and other materials in them. They had to get driven there on trucks, and probably the steel had to get made somewhere and put on a truck or put on a boat that probably burns some fuel to get there. So if you think of the hardware, it goes all the way back. And so how can you be as hardware efficient? So again, efficient code that uses the least amount of hardware is better, because if you get a job that runs with, the only needing one chip on one rack in a server versus 100, that's going to be way more efficient. And it also means like thinking about things like device upgrades, like the longer devices can work, and the more accessible your software is, that means that people don't need to like, oh, I really want to use that great app, but I need to go and get a new phone in order to use it. That's terrible, because that new phone has so much carbon involved. And the final piece is carbon awareness. And that's what I was just talking about with electricity maps. So how could, with the energy that we power, where can we go where there's more clean energy and do more jobs on clean energy, more jobs on grids that have a lot of solar when it's sunny, and less where it's dirty? Like, how can we avoid, if there's a job that doesn't really matter when it runs, why wouldn't you run it in the middle of the day when there's solar on the grid versus overnight where there's gas getting burned? And we'll talk more about some tools for that. But these are the principles of green software. Big pieces of efficiency. Oh, and I'd say the other nice thing is, if you're talking to employers and you're looking at a job, a lot of these efficiency approaches can also save money, which every employer and business loves to hear. So if you write code that's extremely energy efficient, extremely efficient code that runs the lowest possible amount of CPUs and the lowest amount of data center space, that's going to be great for the planet because it burns less CO2. But also that's going to drop the server bills of your company. And suddenly that's like, oh, wow, here's this new developer we hired saving us money. Love it. So let me move on to the tools and show you guys some tools. Please star this repo. There's probably the most important thing that you can do and remember from this talk is to go to the repo. Rosendo put it up on screen, github.com/github/green software directory. Star that repo so that you have it on your GitHub account and you can access it anytime. We just built and launched this repository, and we did a research task internally to try to identify every green software tool that exists on GitHub. And it's basically the open source community's home is GitHub, and so it's nearly every open source green software tool is hosted on GitHub. And we tried to organize them in one place so that any developer could have that resource, and anyone who wants to do green software work can go in and use these tools. We're also maintaining it and updating it. If you know a tool and you don't see it there, please give us a pull request, let us know, submit an issue. But starring this repo will be really important for you because then you'll have access to all these tools anytime. It's also one of the challenges for this hack week. We also have a blog post that's related to it as well, and you can find that as Google, where we went through the top 10, and we're going to be doing more work on the GitHub blog to feature each of the largest tools and interview the creators and have them do demos. So you can also follow the GitHub blog to get more of that and a lot of other great content that our team does to educate developers. We're always doing that. But yeah, github.com/github/green software directory. Star the repo, most important thing you can do, and then you'll have access to all these tools and more over time. So with that, I'm just going to have a sip of my drink, and then I'm going to go through the 10 most starred green software repositories on GitHub. Okay. So this was content from what we put on the GitHub blog, but within the green software directory, we did a ranking exercise where we just looked at all of the tools and we said, all right, which tools have the most stars on GitHub? Because that's probably the simplest way to understand that people are finding them valuable and using them. So I'm going to quickly go through them. I'll share a couple of points about each. I am familiar with them, but I'm non-technical. I'm not a developer, so I can't answer technical questions about them. But I'm sure you could submit an issue or get involved with any of the projects. They would also love contributions, and the contributing to these would be amazing for your resume. Like if you're able to show, look, I used this tool, or I contributed to it, or I built something. I think any employer that's interviewing you would think that, oh, okay, that's really interesting. Contributions to open source projects are really powerful, and this could be a great way to differentiate yourself from other candidates. So this is the number one tool with the most stars on GitHub in the green software space. And I'm going to mispronounce it. So for French speakers on the call, I'm sure there's some of you from France. So it's a tool made primarily by a French team. The tool's name is Scaphandre. And Scaphandre, you'll see the image of the cool old school diving suit. That's what the word means in French. The scaphandre is like the old school diving suit. And I kind of love that because the idea of getting in and understanding green software, it's sort of like you're diving deep in the ocean, because you have to get deep and understand, okay, where is my tech running? And like, what is the amount of power consumption, and what data center are we running on, and what does the grid look like? And so the different tools that we're going to look at help with these. Scaphandre is focused on measuring power consumption from bare metal and virtual machines. It integrates easily with tools like Prometheus and JSON so that you can access it with telemetry tools that you're using. And it gives you power consumption data. So this tool is designed really to help you understand for tech you're building, what's the power consumption? As we talked about, the energy use is one of the most important things for the climate. So this is focused on power. Number 2, Kepler. This tool gives real-time power for Kubernetes environments. It monitors energy usage at the process, container, and Kubernetes pod level. And it's designed for cloud-native environments. So if you're working in Kubernetes, which many of you will be, Kepler's a great tool to check out that, again, can help you on the power energy usage question, similar to Scaphandre, but really focus on those Kubernetes environments. All right, tool number 3, Code Carbon. This one's slightly different than the two before because it doesn't just focus on power and energy, but it goes one step further to think about the carbon-aware computing and the source of energy of the grid. So it focuses on CO2 emissions of code, and it's especially useful for AI and ML environments. And what it does is first it looks at, you can see in that graph in the screen grab from the repo, looks at the hardware energy consumption. So your GPU, your CPU, your RAM, what kind of energy is being produced. And then it looks at the regional carbon intensity of electricity. I believe it actually uses the electricity maps data I showed earlier. It's either them or what time. There's a couple of awesome groups that share power data. And it's a Python package, but what it does is estimates your electricity power, then looks at where the computing is done to tell you the carbon intensity. And so what it tries to do is not only give you the chance to make things more efficient for energy, but also think about, do I really need to run that job here at this time? Where if I could run it in another data center at a different time, it would have nearly no carbon because of renewable energy on the grid. That's what CodeCarbon's all about. Next one, Cuba Green. I love this one because it's a little different than the three I shared that are much more about kind of measurement and then doing the work based on the measurement. Cuba Green is much more about the energy efficiency level. And I like this one because to me, it's kind of feels like the way that, you know, when you leave a room, you turn the lights off. But Cuba Green auto shuts down Kubernetes resources in off hours. So that reduces your energy consumption. So it's ideal in particular for dev environments. So if there's an environment where maybe you're only using it during your workday, that doesn't need to be on all night. And particularly if you're somewhere where there's a lot of solar, if you only have it on during the day, it might just be using solar energy and there's no carbon getting burned. The same environment that stayed on overnight would be running a CPU somewhere and burning gas. Now, the really nice thing here, if you're talking to an employer, is using this tool not only saves energy, but that saves money because it runs less CPUs, it runs less energy, and you need to pay for less of your dev environment. So great way to save money and be energy efficient. Check out Cuba Green. All right, 5 of 10, cloud carbon footprint. Cloud carbon footprint measures and monitors the carbon of cloud services, whether you're with AWS or Google or Azure, and it provides actionable recommendations to cut emissions and cost. So this is particularly useful for an environment where you're using one of those cloud services, which many of us are. And again, doesn't just help you cut emissions, but also means that you could tell your boss and tell your manager, this thing saved money, which every business loves to hear. And it has extensive integration options, so you can see multiple services in one view. All right, number 6, the Carbon Aware SDK. And this is one of several projects from the Green Software Foundation, who I talked about earlier and shared their training. They have the Carbon Aware SDK. They have what they call the Impact Framework. It's a measurement framework that the Green Software Foundation's been building. And they also have developed the SCI, which is a core measurement framework for software carbon intensity. That's a great thing to have in your toolkit. But the Carbon Aware SDK optimizes where services run based on real-time carbon intensity data that they get from electricity maps. So a bit similar to CodeCarbon that I shared earlier. It's designed to allow you to shift workloads easily, and it has a web API and CLI. And there's electricity maps. That's the underlying data. We love electricity maps. Again, another great open source project that you could contribute to that would look great on your resume. From the Green Web Foundation, CO2JS. This is a JavaScript tool. The Green Web Foundation are an awesome group to follow as well. I was talking to their founder, Chris Adams, this week, their lead, who's excellent. It's a JavaScript library that estimates emissions, especially around data transfer. That's a specialty of this tool. Monitors impact through emissions of each byte of data, and it integrates really easy into JavaScript development. So if you're working in Java, check out CO2JS. All right, 3 more to go. Carbon Tracker. This one's great if you're thinking about ML model training because it predicts energy and CO2 use during machine learning model training. What's cool is, so if you're training an ML model out there, this is a really good one for you to follow because it gives you real-time predictions. So the first training epoch you run, it gives you some data so that you can then optimize the rest of the machine learning model training. And that saves money as well as saving energy and carbon. It's a Python tool. It supports Intel CPUs, NVIDIA GPUs, and Apple Silicon. Next up, Kernel Tuner. This is number 9. This one optimizes GPU kernels across multiple compilers. Optimizing GPUs is great because that's expensive and high energy use. It offers auto tune to boost performance and energy efficiencies, and has energy monitoring capabilities such as power capping and clock frequency. And final, number 10 on our list of top 10 tools, Experiment Impact Tractor. Again, ML and AI focused, but this tracks energy, carbon, and hardware usage during machine learning. Gives you detailed logs and carbon impact reports. It's particularly good for academics. This one's a bit more academic than the others. Works on Linux and Macs with Intel CPUs and NVIDIA GPUs. So those are the top 10 tools. All of them are available to you through the Green Software Directory on repo. That's why that's a must star, so that you have that in your toolbox. They're all open source projects. They accept contributions. They'd love to have more people engage with them. Contributing to one of those and being able to talk about it in a job interview would probably really separate you from other candidates, as well as give you great skills to help the earth. So why not? They're pretty cool. So now I'm going to just pivot to finish off on talking a little bit about how we're thinking about impacting the climate positively overall at GitHub. And I think that you might find this interesting just from a GitHub basis, because I'm sure you're a user and we love the developer community. And so how we're trying to make our code as green as possible in partnership with devs. But also, this is a good way to think about how companies are starting to really value and think about sustainability these days and the type of goals they have, and why, if you're good at green software, you're going to be a valuable and interesting candidate as you grow your career. So the mission for GitHub of our sustainability work is to accelerate climate progress through developer collaboration. We're all about developers and how can we have the best impact on the climate. So at GitHub, our parent company is Microsoft, and so we align with Microsoft on all of our core sustainability goals. And so this is how Microsoft, as one of the world's largest companies, thinks about sustainability. And this is really important at the most senior levels of the company. And this is similar to when I was at the start, like why does this matter for businesses? Businesses care deeply about this because employers care, because clients care, because governments and policymakers care. It's critical. Our users care. We need to make an impact, and we have a social responsibility to do so. So at Microsoft, these are our goals, and we line up to them with GitHub. First and most important goal is to be carbon negative by 2030. So by 2030, we're looking to run our operations with less carbon entering the atmosphere than we have to use. The first step is to reduce carbon as much as possible. We have a goal to be 100% renewable energy starting next year. So that means across all of our operations, every data center for Azure, everywhere we're operating as a business, we want to use renewable energy. And so we're trying to help across the globe produce more renewable energy. I think we're one of the world's largest purchasers of renewable energy, but this is all about more solar, more wind, more nuclear, and trying to help transition from burning dirty fuels like diesel and coal and gas and using clean renewables instead that put no carbon in the atmosphere, and also make it better for local communities because there's less air pollution. We also have a goal by 2050 to remove historical emissions. And so Microsoft also has a massive program around carbon removals. And we do all sorts of interesting work to help technology exist that takes carbon out of the air, to also drop the carbon levels that keep going up as society. So carbon's the first goal, and that's kind of the one we talk about the most, but there's more. Water positive. So data centers and business operations use water. Data centers use water for cooling, and it's really important to be aware of the water footprint of your code. So our goal is by 2030 to replenish more water than we consume across our direct operations. And so similar to how we're trying to reduce carbon everywhere, we're also trying to reduce water use. So are there ways to do air cooling instead of water, or really optimize and get really smart about water use to have lowest amount of wastage? And then where we have to use water, we work in local communities to find projects where we can replenish water. That might be doing things like helping farmers have better irrigation, or working with a nonprofit that's restoring a river. But water is really important. Third of four goals, zero waste. So our goal by 2030 is to be zero waste across our direct waste footprint. So if things are made and then get their end of life and are thrown out, particularly when it's e-waste, when it's electronics, every electronic device we have has really valuable metals that have to be mined in them. So we want to reuse that. So a lot of our zero waste approach is about, as much as possible, extending the life of servers and reusing them so that we don't just have to, run things out and replace them. And then our final goal is to protect and preserve ecosystems. So Microsoft has a goal to protect more land than we use by 2025. And we're building a planetary computer, and we're working with NGOs and civil society and governments to help protect nature around the world, because we have to do that to protect society as we grow. So that's Microsoft goals. And then particularly at GitHub, we think about three things. We call them green GitHub, greening our industry, and greening the globe. Greening GitHub is about how can we, and this is our responsibility for us to do internally with our employees, but how can we limit our environmental footprint, limit our carbon emissions, limit our energy use as we grow as a business. So that's why we do things like I talked earlier about the performance engineering that we do, our efforts to 10x our operations as we grow. That's one piece there. Next is greening our industry. How can we help with, why are we doing this? Why are we helping to educate developers on green software? We'd love every developer to understand green software, to give them better tools, to find out how can we can help these tools grow? How can we help skill developers? How can we help the entire developer community work together to limit the environmental footprint of technology as technology continues to grow and grow and grow and grow? And then finally, green the globe. How can we help every developer take climate action and work on climate positive projects? So this is beyond even just limiting the energy of technology we build, but this is about using technology to solve climate problems. One great tool, and I actually just learned this morning that within this Hack Week event, there's going to be a talk by the founder and lead and maintainer of this project, Tobias, open source sustainable technology. This is one of my favorite repos on GitHub. They have a report and a website, but this group has been, as an open source project, mapping all of the open source projects that are climate beneficial. So if you go to this, it's a huge list of open source projects that you could contribute to that would look awesome on your resume, and you could work on anything that's interesting to you. This is this could be things like code that helps renewable energy be more optimized, wind energy, solar, code that helps spot wildfires, code that helps make better weather models. I was talking to a group the other day, Climate Hack AI, who are about to do a hack to map renewables on the India grid and come up with better models with machine learning to work out how to make solar more efficient in India. Like, I love that. Pretty much any area of climate impact, of positive climate impact, there are open source projects that would love more contributions and support. And this would be a really meaningful way for you to do a positive thing for the earth while building your career. So check out that repo to find a great list. And then they also have an associated site, climatetriage.com, with just good first issues from those climate projects. So this is an awesome way. If you'd love to just go and learn some skills, practice your work, get something for your resume, if you're going to go and work on a project, here's a whole list of good first issues. So these are from all of these climate projects. These are the issues that those projects have said, we would love a new developer to come and help on these and get engaged with these. Is a really good way to start to learn our project and contribute. So check out climatetriage.com. So with that, covered a lot of ground. I'll move over to Q&A. I'm going to stop sharing my screen so I can see the Q&A, but thank you. And I'm willing to take questions on anything. Maybe we'll start with some of the green code. I'll see what's come up so far within the session. I'll work through the ones we have, and then I'll take more questions. And I'm here until the end of the session to take anything that you want.
Awesome. So, Paul, I'm just going to help out here. I'm going to put up some of the questions on screen.
Thank you, sir.
This is from the beginning, is probably the first or second slide that you showed regarding carbon emissions. Not Ramesh asks, how much of this can we say is due to software?
Great question. So if we think back to that first graph, it showed carbon emissions starting with the invention of the steam engine. So we've had, as humanity, a lot of years before computers existed. So before the idea of software probably, when do we think software started? Like 1980-ish, I guess, maybe. Like, yeah, Bill Gates in a garage. I think Microsoft's about 50. I guess let's say 50 years. 50 years of software. Now the current estimates, current energy use, we think that all technology or software and associated tech is about 5%. So that includes like undersea cables for internet, for the whole internet running. We probably have all streamed shows recently or streamed downloaded computer games. Like those have big footprints. If you have any Bitcoin or Ethereum, massive environmental footprint for blockchains. Then you get to this growing AI energy use. So software is somewhere within that 5%. So currently, like this year, software is probably like a percent ish. But there's projections that this will grow because there's so much more software and technology, and AI is energy hungry as well. Um, so I think one way to think about it is that the whole technology space is on track to be like roughly equivalent to air travel globally.
Mm.
And so it's significant. Like we're not as significant as the cement industry or the steel industry or cattle. Cattle, the methane that comes from cattle that's grown for meat is massive methane footprint. So we're not as significant as those sources and heavy industry. But yeah, we're there. The nice thing is we also, many of the large companies in the tech space and many of the hosting companies have massive renewable energy commitments. So if you look at Microsoft, Google, and AWS, these are probably the three companies that are buying the most renewables on Earth, which helps. But yeah, so that's one rough way to think about it. There's more reports on it all the time. I think the International Energy Agency has some of the best research on it. So
Absolutely. Yeah. So great topic to have because we'd like to reduce that 5% or not see it increase too drastically over the next couple of years.
yes,
So my O fourth asks someone reminded me that the climate clock has less than 5 years left. What exactly happens when it runs out?
I'm not sure exactly what you're referencing there. There's many different research things that get out there. This one I don't know about. I'll tell you my personal framing on this, and I'm not a climate scientist, but I read a ton of things, and I'm in the industry. There's a big debate in the industry about what we call climate doom versus climate optimism, and it's a spectrum, and different people have different places. There's the science is worrying. So if you really go and read up on the climate science and the impact that it's already having right now, we're already seeing like the major weather disasters. We're already seeing a really hot ocean, and we're seeing corals bleach, and corals are like the rainforest of the ocean, and corals going to be some of the first stuff that starts to disappear, and it's in trouble soon. So there is really troubling stuff right now. But I don't believe there's any like deadline or a climate clock that has 5 years where there's going to be some drastic point. Humans will exist. It's going to get, we're going to have worse effects. We're going to have to pay more for them. We're going to have more extreme weather. We're going to have more species that can't handle the changes in temperature. So the way I think about it is this is a problem now. It's a problem going to be for our whole life. Every year it's on track to get worse unless we start replacing fossil fuels with renewables and working out carbon removal. We've got to get that carbon curve down. It's a whole society that needs to change. But humans will keep surviving. The real long range concerns are probably a couple of 100 years on out. For society, like I look at the Paris Agreement is massive. That set a target of by 2050 to keep society at 1.5 degrees. We believe we'll have we'll avoid the worst of climate change if we stay below that 1.5 degrees. That's the target that humanity has set and that governments and businesses are working towards. That's the target that we all just need to get on board with and do everything we can to stay under. We are on track to currently exceed that, but we have some time. And so I'm hopeful, particularly with new technology, I think there's ways that we could move faster. Like why do we dig stuff up from the ground, dig up oil, dig up gas, dig up coal and burn it to get electricity? Something like 2/3 of the shipping of the those big cargo ships you've seen, about 2/3 of them in the world are just moving around oil and gas. And this is crazy. Like we're technologists. Like I have solar panels on the roof of my house. Like I fundamentally believe we can have 100% clean energy economy like really, really fast. We just need everyone, every business, every individual, every government to like get on board at even bigger levels. So near term, I wouldn't be is that alert, not alarmed? Maybe my posture is to at least like do everything I can. And where I find hope is in the solutions. This is on working on the problem. So if you worry, that's totally understandable. And there's a lot of studies out there that the anxiety around climate's high. That makes sense for me. And there is some research that backs this up. Taking control and having an impact is really matter. So you might try like go to climatetriage.com and hack on one of those projects, learn some green software and start applying it. Suddenly you're doing good and you might start to feel a form of agency. So it's different for different people, but that's my personal read.
Absolutely. So, the next question sort of goes hand in hand with the actions that you're sort of suggesting here, going out and hacking. XDXEXL asks, sometimes they see that some programming languages are greener than others. What does that mean exactly?
Yeah. Axe to Excel, maybe? I don't know. I
Yeah,
probably
maybe.
mangled that. Yeah, yeah. um, I've seen this debate as well. Someone might have better answer than me in the chat, but my rudiment, I'm not a developer, but rudimentary, my understanding is there is like a little bit of a debate on this. Some of you go out and Google and read some good posts on and
Mhm.
things. I do know that Rust is seen as like extremely efficient by a lot of people that are in the green software space. I'm not entirely sure why, but again, I don't think it really matters because like you're going to be an environment where different coders use different languages all the time. Like we just saw Python just became the number one language globally on GitHub, and Rust I don't think was even in the top 10. So I don't know for sure. You'd probably want to investigate that more and talk to more developers. I haven't seen, at least from the Green Software Foundation and others, I haven't seen like the first order thing you should do is think about programming language. It's more about think about energy efficiency, think about hardware efficiency, think about carbon aware. Do those regardless of the language. And because every project in the world is on all these different languages, it's really like we need everything to be more efficient, basically, wherever it is. That's kind of my read.
Absolutely. Next question. So, if my code is efficient in time and space, is this green code, which can help in decreasing carbon emission? And this from Twister Boot 904.
Twisted Boot 94. I love that name. Yes, I believe so. I believe if I'm following the question right, yes. If you had one project that was going to be less efficient and use more CPUs, and hence that would use more energy to power them, and it would require like two CPUs to be produced in the world and scale that out, way better to be more efficient. So it's one of the simplest things to do. It's hard. Can take more work. We're all busy, and we want to get to the fastest solution. But at least at GitHub, this is the first thing we're doing internally, and it's having a lot of impact. And across every part of the business, like we're trying to train every developer and internally really look at like, okay, like when we run a project, like how many CPUs does that use, and is there a way that we could do it in half the amount, the same job? Let's do it. It might just take more coding time. So yeah, I think you've nailed it, Twister Boot. That to me sounds like green coding.
For sure. And there are a ton of questions here. I'm just kind of trying to
Oh,
keep
cool.
everything in
Yeah,
line
yeah.
here.
Awesome.
So, how can we incorporate green software design in the planning phase of product development?
Yeah, I love that question. I love that you're thinking about it. Um, Great question. I would say probably having the people working on the project have a similar understanding of the space would be really good. Like if everyone on the project spent it takes about 20 to 30 minutes to do the Green Software Foundation training.
Hmm.
If everyone did that, it would be good shared knowledge to be as efficient as possible. I've also seen there is an awesome uh, guide for product managers, like climate sustainability guide for product managers that a guy named Francois Bourrat and Peter Stovall have written that I've read and is awesome. And it's a lot of those pieces. There's also someone's written a green design guide. So there's a couple of things out there at a Google that you can find that I think have really good like ideas and processes on this. Um, so yeah, but great thinking. But yes, that's the right time to start thinking about it if you can. Yeah.
For sure. And you kind of alluded to this as well. FlexDev23 asks, how can I minimize the high carbon emissions in software development?
Yeah, I think I covered it in many ways, but go back to those principles.
Mhm.
Are you as efficient as possible? Are you running less machines? Are you being hardware aware? And are you being carbon aware? You do those three, those are the most important things you can do.
For sure. And I think that goes the same for F Francie 404, 4043 here.
Yep.
Optimizing algorithms to reduce computational time and energy use is going to be something that you probably learn in some of the resources that Paul provided
Yep,
earlier.
many of those tools should be able to help. I think even Scaphandre would be a great place to start
Mhm.
for number one, like energy use code carbon as well.
For sure. One of the questions here from Maddie G's with a lot of Z's: should I learn with the Green Software Foundation before trying to contribute to the repos?
I don't think you have to. No. See what resonates with you. Go looking for a good first issue. And get amongst it. You could do, if green software resonates with you, take that path. It is really cool training and foundation. You get a nice certificate that you can just add into your GitHub profile and, like, show potential candidates in future, but you don't have to. And also, you might want to do that at the same time. Maybe one of the open source sustainable technology like pro climate things would be more impactful. And those, you definitely don't have to know green software to go out there and hack on a weather model or whatever it is that gets you most excited on that list.
Here's one that just came in from Shizu. As we use more AI in our daily lives, how can we make sure this doesn't negatively affect our planet? Is it even achievable?
Big question. This is a question that so many people are debating at the moment. My take I will share is, one, I think that AI will have tremendous positive impacts because of all the things it can do for climate. There's a group that GitHub has sponsored, Climate Change .ai, who are a nonprofit who bring together the AI and ML communities and climate research. And they have so many amazing projects that are going so much faster to do good for the world because of AI. Weather models, mapping of forests, like all these projects that, like, the positivity of AI for those areas is so huge. And similarly, the ability for energy use to get way smarter. So massive. How do we do all the good the changes we need to make faster with AI? Secondly, how do we be extremely aware about using green software principles? Because AI and GPUs that power AI are very power hungry. How do we use as much renewable energy as possible? Because AI ain't going away. Everyone's going to adopt it. It's going to transform society. It helps me every day. So how do we firstly make sure that it's renewable energy heavy that powers it? Secondly, be as efficient as possible as we grow and build these tools. Third, I just, like, as an individual, I think about, like, do I really need AI? I don't need it for everything. Like, I have, like, a notes assistant in my Zoom that I turn off most of the time unless I, like, really need it, because I don't need every meeting to have notes and I don't need to run the GPUs. I had my Teams would set off bubbles and balloons when I would move my hands like this, and that's cool, but I turn that off because I don't need it. I don't need to run that machine. So, we don't need to have everything AI because it does have an energy footprint.
For sure. And I'm really cognizant of time here.
Yeah,
There
we're
are
gonna wait.
a
Yeah.
lot of questions. Just last one here from EvoTech22. How do we in developing countries adapt the green software system?
Love that. Also, if people just want to follow me on LinkedIn, I'm the only Paul with two L's. Young on LinkedIn, GitHub. Just follow me there. I share a lot of stuff. And I'm happy to, if I take a question there, I'll try to, like, write a post that anyone could see. So very happy to be followed there. Climate's a problem everywhere. Probably you can follow the same systems. I have noticed there are some data gaps, like electricity maps. Like, I've looked at Africa and some other developing, and that I think there's only South Africa that appears on the map. I find the project that resonates best for you in your context. Maybe it's the green software tools. Maybe it's another one of the open source sustainable tech. I've seen amazing open source projects all over the world that do different things. Like I mentioned, I was talking to the climatehack.ai team the other day who are about to focus on doing solar for India's grid. So you might be able to find something that's even more relevant for your context, or contribute to a project and bring that different point of view, because it might be just people in, you know, the West who've contributed, and they might not have understand an awesome solution that you might know. So yeah, diversity of contributions is really important everywhere. Thank you for the question.
Yeah, for sure. So like we're at time. We have one last question. I think
Yeah,
this person has asked it a couple of times here. So data is increasing day to day, and it takes a lot of like storage and processing to kind of
yeah,
manage this data. Um, what
yep,
can we do to limit CO2 basically? And like,
yeah.
what are your views on decreasing the amount of data that we need to
Oh,
manage?
Twist a bit again. Twist a bit. Hey, love the
Yeah.
name. Um,
Mhm.
No, I think you're onto it, right? Like efficiency everywhere matters. Like, why do we need to store everything forever? These are great questions, and I think ones that you could tackle in your business or everywhere. Like, because the nice thing is, this also strikes me as the type of thing that you might go get a job somewhere and be like, wow, we store like 200 years worth of meeting notes. Like,
Mhm.
why do we need these? Like, let's delete them. And suddenly that storage fee went from like $3,000 a month to $50 a month. And guess what, boss? I just paid for my salary. I don't know. That's a bit of an exaggeration, but yeah, efficiencies are everywhere. And if we don't need to keep stuff, like, do we really need to? Because it's easy. Because somewhere out there that's going to be running a machine, and that machine's going to be running energy, and we don't need more carbon in the air. We need less.
Absolutely. Um, Great answers, great questions. I think that that is all of the time that we have for today. Really, thank you so much, Paul, for joining us and for gracing us with your presence and all
Love it.
of the wisdom that you brought. For folks that want to continue along in their journey with green software, make sure to join us on Monday, where we have an additional GitHub sustainability workshop that Paul had alluded to earlier
It's
in
going to be
the
Tobias from Open Source Sustainable
yes.
Tech. He's going to be awesome. I'm going to tune in for that because I love what they're doing. I think it's going to be really good.
Wonderful. And yeah, if you have any other questions, Paul's LinkedIn is LinkedIn chat. Feel free to hit him up on there and ask the questions that you need to get answered. All right.
Thank you all.
Uh, Appreciate y'all. Have a good one.